In this example, we're going to look at how to subtract rational expressions. So here we have x plus 5 over x squared plus x minus 2. And from here we're going to subtract 2x over x squared minus 4. Remember, rational expressions work very much the same way as plain old fractions. And in fractions, to add or subtract, we're going to need a common denominator. So we're going to basically find a common denominator first, and then go ahead and subtract these. So here's our example again, same problem, just a little smaller, so I have a bit more room. The first thing we're going to do in order to be able to subtract it and simplify it down to just one rational instead of these two is to factor pretty much everything you see. Anything that's got more than one term, we want to factor so that we really know what we're working with. So for our first one, you notice x plus 5, there's really nothing we can do with that, so we're going to leave it x plus 5. I'm going to go ahead and put it in parentheses though, so that I see it as a factor, and I realize that I did try to factor it. There just was nothing other than 1 to factor out. Next up, we have this denominator, x squared plus x minus 2. We're going to go ahead and factor that. You can use any technique you want, but we're going to end up with the factors x plus 2 and x minus 1. So this is our first rational in factored form. From here, we're going to subtract our second one. For the top of this one, 2x, there's only one term. There's really nothing to factor, so I'm going to leave it just as is. Instead, I want to pay attention here to the denominator, x squared minus 4. That's the difference of squares. So we know when we factor that, we're going to end up with x plus 2 times x minus 2. Now from here, we have everything we need to create or to find our lowest common denominator. So in order to go ahead and add these, we need both rationals to have the exact same denominator, a common denominator, and we want the smallest one possible just to keep the problem as easy as possible. So what we do is we look at the denominators we have and we see if there are any factors in common. And you notice we have x plus 2 in this one, and here x plus 2 again. So the first thing we're going to write down for our common denominator is that x plus 2. Since it's in both, we're going to list that first. You notice it's in both of these, but I'm only listing it once for the pair. Looking at it, there are no other common factors in these two. So at this point, all I do is list everything else that I've got left. For the first one, I've got this x plus 1, so I will write it down. And that's x minus 1. I think I said x plus 1. X minus 1. For the second one over here, we've got this x minus 2, so we need to include that as well. All of these together, x plus 2, x minus 1, x minus 2, that is my lowest common denominator. That's what I need both of these to match in order to actually be able to do the subtraction. So looking at the first one, you notice that I have the x plus 2 and the x minus 1. The one I am missing is the x minus 2 term. So I'm going to go ahead and multiply that in to the bottom. Multiply it in right here. If I multiply it into the denominator, since I don't want to actually change what this rational is, I don't want to change the fraction, I just want to change the way it looks, remember, I've also got to multiply it into the top. So I'm going to multiply the missing factor from the common denominator, x minus 2, into both the top and the bottom. Now looking at our second one, we've got the x plus 2, we've got the x minus 2. The one we're missing is x minus 1. So we're going to go ahead and multiply that in to the bottom. Once I do that, you notice now the denominators match, and that's exactly what I want. I want them to both be the same. Again, if I multiply it into the bottom, I got to multiply it into the top. So I'm going to multiply that x minus 1 into both the top and bottom. Let me move this up so I've got a little bit more room here to work. We want to go ahead and actually rewrite this now with the common denominators in there, so we can see what we're actually working with. And for the first one, we've got x plus 5 times x minus 2 over all three of these, x plus 2, x minus 1, x minus 2. This is minus my second one, where I have 2x times x minus 1, and this is all over all three from the common denominator, x plus 2, x minus 2, x minus 1. So other than order, you notice that my denominator here matches my denominator here. I now have a common denominator. This means I can go ahead and actually do the subtraction. When subtracting rationals, it works exactly the same way it works with fractions. When the denominators match, we're simply going to subtract the tops, the numerators, and put them over the common denominator. So I end up with x plus 5 times x minus 2 minus 2x times x minus 1, and this is over the common denominator, x plus 2, x minus 1, x minus 2. Though it's tempting to look at this and think about trying to cancel things out. I mean, after all, we do have an x minus 2 here and an x minus 2 here. I've got an x minus 1 here and an x minus 1 here. You can't simplify yet. Remember, you can only simplify or cancel out factors, and these are parts of terms, so we can't do it yet. We're going to have to simplify what's here first, meaning we're actually going to have to FOIL this one out, multiply it, and here distribute. After we do that, we can combine like terms, factor, and see then if there's anything that we can actually cancel or simplify to simplify the rational expression as much as possible. So in looking at this, for our first one, when we FOIL this out, we're going to end up with x squared minus 2x plus 5x minus 10. Distributing this minus 2x through, we're going to end up with minus 2x squared plus 2x. And remember, this is all over my common denominator. X plus 2, x minus 1, x minus 2. We're not really doing anything with that denominator right now. We just don't want to forget about it and somehow eliminate it from the problem. So looking here, we do have like terms, and in fact we have a couple of convenient like terms. If you notice, this guy right here and this one here, the minus 2x and the plus 2x, they're going to add to 0, so they're just going to cancel out. So we can just eliminate those. Then looking at the rest, we just need to combine what we've got. We've got an x squared term here and a minus 2x squared term there. Those are like terms, so we can put them together. And that's it now for like terms in the top. So once again, we move this up so I got a little bit more room to work with. And we have, well, x squared minus 2x squared is going to give me minus x squared. I have plus 5x and minus 10. It's combining all of the like terms. This is over my common denominator, x plus 2, x minus 1, x minus 2. Now, if we can factor the top, we can factor and then see if there's anything that's going to simplify, meaning that we can cross stuff out if it's in both the top and bottom. But looking here, the top is not going to factor. Minus x squared plus 5x minus 10, even factoring out a negative 1 to make the first part positive, is not going to factor. Since it can't factor, there is nothing to simplify, and this becomes our final answer. So here we go. The solution to this problem is minus x squared plus 5x minus 10 all over the common denominator, x plus 2 times x minus 1 times x minus 2. Thank you very much.